Okay, today we start actually the 8th grade work. Very excited, our first 8th grade lesson. And it is about rational numbers. We talked about some rational numbers before. And usually when we talked about them, it involved a Venn diagram that looks kind of like a donut. We put whole numbers, and then we put integers, and then we had rationals. So whole numbers are rationals, integers are rationals. A rational can be a percent, like 40%, or it can be represented as a decimal. It can be a fraction. It can even be a mixed number. A rational number is any number that can be written as a comparison. Or sometimes we say fraction, but it is a comparison. Because the root word is ratio, and ratio is also a comparison. Usually it is expressed as a fraction, though. So for example 1, we're going to express 0.45 as a simplified fraction. And if you don't remember the place value, beside the decimal is the tenths place. Then next to that is the hundredths, then the thousandths. So since the last digit is in the hundredths, that means it's 45 over 100. And we need to simplify that, so we could divide by 5. If we divide by 5, we get 9/20. Then we have repeating decimals. Repeating decimals are the decimal form of a rational number that contains a digit or group of digits that repeat indefinitely. The decimal form of a fraction that contains a digit or group of digits that repeat indefinitely or forever. For example, we're going to express 0.7 as a fraction in simplest form. We're going to do it algebraically. So first we're going to let 0.7 equal, first we're going to assign a variable, and a variable is a symbol for an unknown number. It's usually a letter that we use. Sometimes we use little symbols like, triangles. So we're going to assign a variable to the value 0.7 repeating. Let n equal 0.777. Then perform an operation on n to determine its fractional value. So we're going to start with n equals 0.777 ... And this is kind of complicated, but stick with me. You'll get it at the end. We're going to multiply each side by 10 because one digit repeats. Since there's just one digit repeating, we're multiplying by 10. So 10 times n, and on the other side we have to do the same thing, 777 ... times 10. Then we're going to, by multiplying by 10, that moves the decimal point one place to the right. So this will still be 10 times n, and this one will move the decimal over, so it'll be 7.77. Then we're going to subtract the n, because we want to take away the n. And n is the same as 0.777. Sorry, left off one of my sevens. So if we take away an n, that would leave us with just 9 n's. And over here, that takes away the repeating part, so I just have 7. Then we want to solve by isolating n. Isolating means to get alone. So we want to get the n by itself. Since 9 times n, that's multiplication. We want to do the opposite of multiplication, which is division. So I'm dividing both sides by 9. When I do that, 9 divided by 9 makes 1, and 1 n is just the same as n. And on this other side, it looks like I've made a fraction, 7/9. And if you'll remember on our chart that we were supposed to memorize, 0.7 repeating is equal to 7/9. This is how we can figure out what a repeating digit is if we don't have it memorized. Before we go on to the page that you're supposed to be doing, let's try another one. This time we have 0.13 repeating, and we assigned it to a variable. Remember last time we let it repeat 3 times and put the ellipse behind it. And then we multiplied by 10, but we multiplied by 10 because there was 1 digit repeating. This time there's 2 digits repeating, so we're going to multiply times 100. How many zeros do I have? 2. So I'm multiplying by 100 because there's 2 digits repeating. So if I multiply this times 100, I get 100n. But if I multiply this times 100, I'm going to be moving it 2 spaces, the decimal 2 spaces, which makes it 13.13. Because when we multiply by a multiple of 10, we're just moving the decimal however many spaces there are zeros. Okay, then the next thing we did was we took 1 away from both sides. Take an n away from both sides. And n equals 0.13. So if we take that away from both sides, I get 99 n's over here, and over here I have just 13 because that all goes away. And then we want to isolate by doing the opposite of multiplying, dividing both sides by 99. If I divide both sides by 99, these cancel and n is by himself, and I have 13 over 99. Now let's try some of those examples you're supposed to be doing on your independent practice. Let's try 3 first, because 3 is not repeating. So 5 is the whole number, and that last 5 is in the hundredths place, so 55 over 100. Can't leave it like that. It's got to be simplified. If I simplify by 5 on both, the whole number still stays 5. 55 divided by 5 makes 11, and 100 divided by 5 is 20. And that's it. Now let's go do one of these repeating. Let's start with number 1. I hope by now you've kind of realized there's a pattern. However many digits are repeating, that's how many 9s you get on the bottom. So instead of going through all those steps, let's just put 45 over 99 because there's 2 digits that repeat. However, both of those numbers will simplify by 9. And if I simplify by 9, I get 5/11. And this one was negative, so it needs to be a negative answer. Negative 5/11. Let's go ahead and try number 2 together. There's 2.7 repeating. 2 is the whole number. 2 stays the same. 7 is the digit repeating. There's only one digit, so it gets 19. That's it. Let's look down at the bottom. Do you see any problems that have 9s on the bottom? Not really. Number 7 is one that we should have memorized by now, and so is number 2. I'm sorry, number 8. Don't forget the whole number 2. And number 9, we need to just change that to something with 100 on the bottom, and that'll tell me what the decimal is. Same thing with number 10. Change it to something with 100 on the bottom. So let's look at 11. Remember, if you can't change it to something with a 10 or 100 on the bottom, then you have to divide it out. 4 is the whole number, but to figure out the decimal part, I'm going to have to divide man, horse. So 6 goes into 50 8 times. 2 left over. And then 6 goes into 20 3 times with 2 left over. So the thing that's repeating is the 3. Need to put it back with the whole number. And that's my answer. For number 12, you're going to have to divide again. The whole number, -1, stays the same, but to figure out what the decimal is, you're going to have to go divide and work that out.